We are from the Alternative Energy Enterprise, and I'm John Bond, part of the Biofuels team.
I'm Anna Brown, part of the Curb team.
Christina Mills, part of the Biofuels team.
And Jim Smith, another part of the Biofuels team. And today we're going to cover the accomplishments of the enterprise over the past academic year.
The Alternative Energy Enterprise has a current enrollment of 53 students who work on 9 different project teams. Almost every team has at least one student completing their senior design capstone through their work. While the Alternative Energy Enterprise is an entirely student-run enterprise, we are lucky to have 2 great faculty advisors, Jay Meldrum, the director of the Keweenaw Research Center, and Dr. David Shonnard, the Robbins Chair and Professor of Chemical Engineering.
The enterprise's 9 project teams are dedicated to the common goal of researching and developing novel ways to produce energy and promote sustainability in unique applications. But, as you will see, each has been tasked with something very different from the rest. The collaboration of our efforts coalesces into the mission of the Alternative Energy Enterprise, like individual streams combining into one. The shared goals of sustainability, community outreach, and design unite the work of all the teams. We share in each other's successes and exchange knowledge, which propels us all forward. This year, the Biofuels team worked on 2 projects which share the goal of producing a gasoline alternative through the process of pyrolysis, or thermal degradation. In the fall semester, the team worked on calibration and testing of an existing pilot reactor with the goal of converting poplar wood chips into a liquid fuel. They also began researching ways to catalytically upgrade the products. During a run of the plant, an immovable blockage formed which prevented further conversion. The team decided to put this project on hold until they could effectively address the problem and pivoted to another, plastic pyrolysis. This spring semester, the Biofuels team has worked with Dr. David Shonnard and Dr. Ulysses Cressida Alvarez on the design and construction of a new reactor with the goal of pyrolyzing plastic into usable fuel. This has included assembling and calibrating the new reactor's heating control system, evaluating safety concerns, and preparing for a run. The team is currently working on researching more efficient methods of heating the reactor and insulating it. This project has great potential to recycle waste plastics and expand to other plastic types that are difficult to recycle using conventional methods.
In the past year, the Compost team has worked to identify a composting strategy to be implemented at the Wadsworth Dining Hall on campus. From their decision matrices, the composter that was chosen is a food dehydrator which can turn 250 pounds of food waste into 25 pounds of dry compost every day, fully composting the daily food waste from the dining hall. This compost can then be used as nutrient-rich fertilizer to be mixed with the soil. Since the team's goal is to grow food with this fertilizer, they are researching what ratio of soil to fertilizer is most effective for plant growth. This will be accomplished in 2 ways. 1, by analyzing the nitrogen, phosphorus, and potassium, or NPK content of various soil and compost mixtures in the leaf lab, and observing the variations in growth of Kentucky bluegrass when these mixtures are put to use. The compost team has designed and began developing a growing bed for these experiments, which will include an automated watering system and growing light. The team has also prepared sample mixtures to be taken to the leaf lab when it reopens.
The DNR Hydroelectric team is working closely with Michigan's Department of Natural Resources to help design and implement hydroelectric and solar energy generation at the Platte River State Fish Hatchery in Beulah, Michigan. This location was chosen because of its ideal characteristics for hydropower and existing infrastructure. This will assist the hatchery in offsetting their carbon footprint, saving money, and spreading awareness about renewable energy to the public.
On the topic of solar energy, the enterprise has 2 more projects involving its application. The solar analytics team involves designing a system mounted on the side of the Michigan Tech Lakeshore Center in downtown Houghton, Michigan to help reduce energy costs and demonstrate the university's support for renewable energy. The Fortune Lake Solar team involves designing a system mounted on treehouse cabins at a summer camp in Crystal Falls, Michigan to power small loads completely off the grid. These projects both demonstrate the unique way that the enterprise combines the goals of sustainability and community outreach into tangible achievements. The Renewable Energy Mission Module team has undergone a large change recently. Originally tasked with retrofitting a large-scale REMM unit donated from Oshkosh Corporation, the team decided to restart the project with the same goals and the vision to create a smaller scale of the original REM, and then upscale the system to serve as a mobile energy station that can be used for disaster relief in remote areas where fuel may be scarce. Right now, the system design includes 3 primary components: a generator, battery, and a testing load they are driving with the system. The team is also focusing on designing a control structure to give access to live data on the system's health and the ability to make the system smarter in the future. The past 2 semesters have been focused on constructing the core systems from last year's design, including a generator, battery, and load subsystems, and also on integrating projects that include a turbine, solar panels, and battery management systems.
The geothermal team's current project is new to the enterprise this year. This project is focused on understanding the feasibility and developing efficiency data for a heat pump to be operated at the temperature of water in local mine shafts. More specifically, they are working to identify the coefficient of performance of such a pump and compare it to that of the manufacturer's specifications.
The goal of the Sustainability Demonstration House, or SDH, has been to retrofit the former Kettle Gun Lake residence into a sustainable house that is energy and water efficient. Furthermore, the house serves as an example that the community can learn from through its many open houses and community engagement events. The house currently has several previous projects in place that are used by its tenants, such as aquaponics, hydroponics, and solar panels, which help power the building. They also have updated many of its fixtures and appliances to reduce their energy consumption, such as using low-flow faucets, induction cooktops, and smart light bulbs. This year, the SDH team has focused on a plastic recycling process and a greenhouse. The plastic recycling process takes the HDPE plastic that makes up milk jugs and shreds, melts, and carves it into something new. HDPE was chosen due to its popularity in single-use items and its relatively low melting temperature. So far, the team successfully converted milk jugs to 5 3-digit numbers to become SDH room numbers. The SDH greenhouse was built to demonstrate that gardeners in the Upper Peninsula can have an extended growing season. Design elements like structure, materials, and ventilation were reviewed with decision matrices to come to the best conclusion. Heating and irrigation are the most important factors to the greenhouse, and as such, it is heated with a solar air heater and water using dripline irrigation that is separately automated. The SDH focuses on outreach by helping the community learn about their projects through open houses and workshops multiple times a semester. Each open house features a tour, as well as booths of information and games for kids to enjoy learning as well. The SDH's outreach involves local businesses too. This year, the SDH is working with Siberia Cafe Express to compost coffee grounds, thereby eliminating waste and demonstrating the community's commitment to sustainability.
Finally, focusing on the energy aspect of the SDH, the curb team was tasked with installing curb units into the breaker boxes of the house in order to allow for real-time energy monitoring. With the units installed, the team will use data from the house to recommend behavioral changes to the residents, potentially saving 10 to 15% on their monthly energy bill. Then, the house's energy use will be compared with data from the Western Upper Peninsula, the Midwest, and the US to demonstrate how much money can be saved by being energy efficient.
Thank you to our sponsors and advisors, and thank you to you for your time. We hope you enjoyed learning a little bit about what the enterprise has done this year.